Um, Damn it, terminal. One second. It is. I can't really use full screen mode because I'm sharing to you guys. That's why it's a little hard to keep everything organized. But yeah, it works. So now I will do the exact same commands that I did before. Like if you look at my if we look at my PPT, the same things that you can do for taking off without gazebo, you can do the same things for taking off with gazebo. So let me do that here. So I'll do, like I said before, look out for these two commands. The EPEKF3 using GPS. Just like look out for those commands. Those are very important. Yeah, so you type mode guided to enter guided mode. You will see the acknowledgement here. Then you will type arm throttle to arm your throttle. And if you look in the uh, yeah, so then I'll type take off 10. And you can see the drone taking off here. Yeah, you can, as you can see it here. Now let me right click this iris drone and follow it. Yeah. So what follow basically does is it'll always keep the thing intact, like the camera in. So now let me do what I showed you in the first part of the session. I will right click somewhere on the map and I'll type press fly to. I'll put altitude as 10 and I will press OK. And the drone on the map and the drone on Gazebo will do the same thing. They will fly forward until it reaches that position on the GPS. So this is the cool part that I wanted all of you guys to see, uh, and that took me a while to figure out. It is basically that you can use the same thing that would happen in real world. You can do it in Gazebo. So you don't actually need to buy a drone in real life. You can basically like learn everything in Gazebo. And the advantage is it prepares you for a lot of robotics applications. Like knowing Gazebo beforehand, before joining any robotics team or any job, will serve you greatly. So yeah, I would recommend you guys follow if you're not following along right now, I'd recommend you guys again to do it at your do it when you have free time after this session. So yeah, as you can see, it did basically that. Now let me show you all the commands that I did show you before, but on Gazebo instead of just on the map. So I'll do position 0. I don't want it to fly up or forward. I'll move it like 2 meters to the right and 1 meter up. 1 meter up is -1 because it's in down coordinates. And you can see it going to the right and going up. And if you look at the altitude, it shows 10 meters, but it's actually 11 meters. Like, okay, I'll make the, yeah, it will go between 10 and 11 because it's not that accurate. But yeah, to make it clear, I'll do the same thing, position 0 to -5. And it'll go 5 meters up. So yeah. And by the way, like I mentioned a lot of times before, even if you have a real drone, it'll behave exactly the same way. Like there is no difference between how it behaves in Gazebo and how it behaves in your real drone. So I think I've covered a lot till here. Like if you guys have any doubts, you can ask now. Oh yeah, the session is getting recorded. Uh, Thank you, Upasna. Oh, yeah. So if the session is getting, I just realized if the session is getting recorded, you can watch it again and follow along at the end. It took me a while to like get all this like working there. They will, if you try doing this on your own by following the documentation, you will run into quite a few errors, and it will be a little frustrating to debug. So I recommend you guys follow the GitHub that I've sent instead of following the documentation. That so that you can skip all the frustration and directly get to the working part. So yeah, just to show you guys if you had missed if you couldn't visualize it when I showed it on the map, I will show you all the position, velocity, and all those commands. So the first thing that I had shown, let me go back to the PPT so that you guys can, uh, well, not the PPT. I'll go back to the GitHub so you guys can realize it's the exact same thing. It's all under terminal commands to control the drone. This uh, subheading has all of this. So position and ED, I showed it to you guys. Velocity XYZ, I will show it to you right now. So let's say I wanted to fly forward at 10 meters per second. I will do velocity 10, 0, 0. And it will fly forward at 10 meters per second, which you can see is pretty cool. So like you don't really need to um, use a joystick to control a drone. You can basically control it with your computer. And the reason why I'm stressing so much about terminal commands is because controlling it with a joystick, all it's basically like it's fun, but it's not that useful. The real use of drones comes when you can plug it along with other applications. So let's say I build a real drone with a camera, and I have I'm getting the camera feed back to my computer. I can do so many powerful things. Like for example, I can fit the drone's camera with a thermal sensor, and then I can say, let's say I deploy it at like an airport, and I say follow. I can look. This is a real thing that is done in airport security cameras, by the way, but you can do it with drones as well. Basically, what they do is they look. They have thermal sensors on all security cameras, and anyone who has a high body temperature will be monitored across by computer vision programs across the airport. The reason why they do that is because even if someone is does not show out, if someone has malicious intent, they will inherently have a higher heart rate and higher body temperature. So the checking just their body temperature is very useful to find out most criminals like outright. I have had experience with that personally in an airport, which I will not share. So yeah, but yeah, you can think of all the amazing applications you can do with drones if you just have a terminal with you. Like let's say you can, let's say your real drone has a camera and a thermal sensor. I can just script it to, I can get the thermal camera feed and the actual camera feed to my computer, and then I can run Python scripts with OpenCV with computer vision to check to like for example just like follow the person who has the highest body temperature in the room and it'll do that. All that you cannot do with a joystick. Learning joystick command learning joystick control is basically useless for most cases unless you're flying with camera feed and you want to do manual control. So yeah, I strongly recommend you guys like learn more about this like when you have time. So yeah, I'll continue with the commands. Let me like to turn it around to face the runway directly, let me use a set yaw command. I'll set your I don't know, 180, 10, 1. What this will do is it will turn it around at to 180 degrees at a speed of 10 degrees per second, I think. And the number 1 basically just sets it to uh, relative motion. Like relative motion is the most useful because you want to move it relative to itself at the current time. So as you can see here, it's turning around to face the runway. And the thing that I did here, the right click follow is very useful because you don't need to keep following the drone manually. You can just let the program do that for you. So yeah, that is the turning around command. Just for fun, I will show you the position command with a forward motion along the runway. I'll do position. I'll do position 100, 0, 0. This will basically move 100 meters forward and it'll be going a little fast. So I'll do set speed 10. Oh, sorry, set speed 5 and it'll go slower. If I do set speed 2, it'll go slower. Like, and you can watch it on the airspeed monitor. You can see my airspeed being 2 meters per second right now. If I do set speed 5, the airspeed will go up to 5. So yeah, the drone is a little far away. It has to like yeah, gazebo's like a little slow at following drones. But yeah, eventually you can see the drone here. Like I think you can see it here. But yeah, so that was the set speed command and the position command. You saw the set yaw, you saw the velocity. So yeah, for all purposes, that is the basics of controlling a drone with a terminal. Now, I for any of you that is interested, you can look. I will give you the names of the things you have to search. So actually, I'll make a text file for you guys so you can. Uh, I'll send this to you guys in the post. So things you should search for. So the autopilot the command the terminal that I was using, it's called map proxy. So terminal ground control station is called map proxy. So if you just search map proxy command, you can see it here. Yeah. So if you just like click this map proxy cheat sheet that comes up, you will see all the commands you can do. I haven't showed you a lot of things like uh, fences and things like that. I That will make the session a little complicated and also hard to follow. So yeah, like I will stick to the basic velocity commands right now. But for anyone that is interested, and I recommend this to all of you, check out these map proxy commands and try to use them on your simulation. You can look at the documentation to understand how it works. And yeah, so that is one thing. And so this is the first thing that you should look for. The second thing is creating your own world in Gazebo. Uh, and so this is little advanced. Basic. Yeah. So the I this one I don't recommend you guys to yeah, for anyone who has technical knowledge already, I would recommend this. If you're not used to messing around with terminals and Linux places, I wouldn't recommend this. So I'll stick to the basics first. I would like you guys to learn the terminal ground station control station map proxy, and then the graphical ground control station, Q ground control, and mission planner. These are two pretty famous ones that I use, and I'm pretty sure if you join any drone related job, you will be messing around with Q ground control and mission planner. And then what else do you have? You have so I would recommend you guys like search about flight controllers, PDB and Pixhawk. Where I'll give you a bunch. PDB, Pixhawk. I'll add more if I think of them. And then there are alternatives to autopilot, such as PX4. Yeah, so these things I will add more to this list and send it to you guys. But the point I'm trying to make is there is a lot of research that you can do and get yourself good at gazebo and autopilot, so that you can you can be better than other people when you're joining robotics fields. Yeah, which is pretty useful. So coming back to this, I don't think there is much else use for this gazebo thing that I've opened. Uh, so yeah, there is one last thing that I wanted to show you guys. It's called waypoints. So I'll close this gazebo world for now, and I'll close this map proxy thing. So waypoints I haven't really added in my GitHub, and the reason is that it's actually, I will add it soon. Like I'll add it right now. Like the GitHub will be updated very shortly with waypoints. Waypoints, what they are is, let's say you are making an autopilot mission. An autopilot mission is basically what all of our commercial planes use while taking us places. It basically gives it a set of GPS points to follow to follow a right path. So to do that, let me open the uh, a map proxy like I showed. I'll be using the word map proxy from now. Map proxy is basically the ground control station. So when I say running ground control station, that is basically running map proxy. So let me open up this command. And wait for it to load up. Yeah. By the way, if you hadn't noticed, dash L KSFO, dash L basically gives you a location that you can spawn it at. So if you were there at the beginning of the session where I said you can put it at your house, this KSFO can be replaced with the map GPS coordinates of wherever you are. So if you can just get your position on a GPS and enter it here, yeah, you can basically make the drone spawn at your house. The simulated drone, that is. So yeah, let me keep the console on top, keep this on top, and keep this on top. Okay, now what I wanted to show you was waypoints. So the way you do that is, let me right click, and there's this option called mission. This is what I wanted to introduce you guys to. You go to hover over mission, and then type click editor. This will open up a mission editor for you. The mission editor is here. Let me take this off while it's on top, so you can see the editor. Yeah. So this is the mission editor. What this kind of interface you will see everywhere, like when you use any ground control station. All your commands will show up here, like when you press. Let me show you the way you create a mission. So first of all, you right click on your drone, the place where your drone is. You go to mission. Sorry, you go to mission and you click add takeoff. Type takeoff altitude 20 meters. Yeah. So once you added a takeoff, that will set the takeoff location, and then oh sorry. Yeah, so once I've set the takeoff location, I will right click somewhere and type mission draw. It will let me draw a mission to like start like yeah. So I'll set the mission altitude to 20 meters, and I can basically just click on different places, and it will start drawing a mission for me. So what I'm doing now is it will take off at wherever I've pressed add takeoff. Don't worry about this. Like this isn't anything. Uh, it'll basically follow the blue line that I've made right now. So I can add points as much as I want. And then when I'm done adding points, I can right click and it'll get ready. It'll get made. So yeah, so now like my mission, wait, let me clear this actually. And yeah, so now that it's synced, let me add the takeoff again, mission, add takeoff. Okay. Now you will see the takeoff showing up on your mission editor. It was supposed to show up. I don't know why it didn't. So once you right click and click add takeoff, it will it'll add it to your mission editor. And then the next step is to right click mission draw. And you set the altitude for the mission to happen at. And then you just start clicking. Let's say I wanted to first go to this place in the runway, and then I wanted to go to this building, and then I wanted to go to this runway, and then I wanted to come back here. Then once I'm done doing this, let me right click and it'll be done. Now I'll right click on the map again, type mission loop. What loop will do is it'll like complete full loop. So it'll keep looping here as much as you want. So now what I'll do is I'll press right. WP is waypoint. So it'll write waypoints. So it'll basically write it to the drone. And then what you can do is save this to a file. Let me save it in my desktop. I'll save it on my desktop and I will name it as waypoint file.txt. It will be saved as a text file. So if you open up this text file that it is made, this is what it will make. It will basically have a list of GPS coordinates and other like parameters that the drone will understand. But that isn't really important for us. Like we wanted is to do the mission that we made. So what I'll do is it is this command. So just like I showed you before, do mode guided, arm throttle, take off 20. And then while it's taking off, let me type auto. What auto will do is it will put it in automatic mode so that it will follow the mission that I've made. So if you can look at the map, this is actually pretty interesting. This is like the most useful feature that you will have in, not the most useful, but it is a pretty useful feature that you will have in your ground control. So if you can see here, the drone is currently flying to the first point that I put. But now without any of my intervention, once it reaches the first point, it will automatically shift to the second point and move there, as you will see now. Yeah, so as you can see there, it's basically following the path that I made. And the reason why this is so useful is this. So let the drone keep doing its thing. I explain it with the mission editor. I'll keep this side by side. Uh, so the commands that you can see here are basically whatever they say. Nav takeoff is a takeoff command. Nav waypoint is a waypoint that you've added. Do jump is basically what I did when I pressed loop. So do jump basically just goes to the next waypoint. It basically just goes to the next waypoint, which is the first one, and then it keeps continuing indefinitely. Now, let's say I wanted to do other things. Like let's say I'm not being serious, but let's say your drone has a servo motor that can drop payloads, and the payload is a package or a bomb or anything like that. You can you can add commands here, and you can see all of these commands that are possible. One of these commands is called do start. It's called do set servo. Well, this command is pretty interesting. You can basically map the command to any servo motor on your drone. So let's say my drone has uh, it has a package dropping mechanism, and I'll set that to this thing while configuring it. Then what I can do is while going to any waypoint, I can just press do set servo, and I can add the command that it has to do, which like I will not go into the details right now because it will become complicated. But once you do that, you can basically do something like while it's going here, go to that house and drop this package or whatever else, and then continue with the mission. So like as you can see now, with just this map, you can basically do like a drone delivery sequence. What you can do is your house is here, you right click mission, sorry, you right click mission, add takeoff, and then you go to your destination, you move on to your destination, you type coordinates. Let's say my destination is here. I'll right click mission, uh, draw, and I will draw like the path it has to follow. And then I will set this server to drop the package wherever it is. And then I will just like set the next waypoint as my house. And what the drone will do is it will go there, it will drop the package, and it will come back to my house. So as you can see, it's very useful, but I cannot go into the details right now because I cannot make it too difficult for you guys to follow. But I will add it here. I will add it in the text file for you guys to read up about it. 1 second, I will get to this question in 1 second. So this is setting. 1 second. Yeah. So how do I name it? Alternate. Wait. Autopilot missions. Waypoints. Do set servo. Yeah, things like that. I will modify this text file and send it to you guys. But yeah, you guys can like check, look online for autopilot missions to understand how like the various things you can do with this. But like I think you get the idea here. It is very powerful, and you can do a lot of things with it. So for what Namet has asked, you don't need a Raspberry Pi. So so when I said, oh wait 1 second, let me go to the beginning of the questions. Yeah, can you do all this in a real drone? Yeah, you can. Like any drone that can run autopilot, the software can do all of this. Like I mentioned, the gazebo, whatever you could see on the gazebo is what you can see on your real drone. So like in the PDB flight control that I had shown, 1 second. Yeah. So yeah, in the PDB flight controller, uh, it basically has a whole chip for processing. So it's not just like it isn't that power. It isn't that computation intensive. So like just because you had asked this question, I'll explain this one thing called Mavlink. Mavlink is basically it is a protocol called Micro Air Vehicle Link, and it's a protocol that lets you do simple tasks with simple commands. Like for example, my takeoff 10 command is will only take a few bytes of memory in the flight controller storage. So it's actually like it is very lightweight, and the reason they've done it is this: like you can uh, do autopilot missions and things like that without having needing much computation power on the board. So, like you had asked, a Raspberry Pi has a lot of computation power. Like it can basically run a whole desktop. But all you need for this, for following the commands that are sent through a terminal, are like a few megabytes of RAM and like a few like kilohertz of processing speed. So yeah, so to answer your question, you don't need a Raspberry Pi to do all this. All you need is a flight controller, like any flight controller, like SpeeDB or I had only looked at SpeeDB and Skyline a little bit, but there are a lot of other flight controllers like these, like Matic, Pico, and stuff like that. I haven't seen much about them, but yeah, you can if your intentions are to make a real drone, you can look into these. Just search flight controllers, and you can get a lot of things for a lot of price points. So yeah, you don't need much processing power uh, to follow all this. And if you, I'll actually add that here. Uh, Learn about Mavlink. Yeah. So Mavlink is actually a really smart method of communication. What it does is it all Mavlink does is send integer numbers to the drone. Like let's say I think so. Let's say I type takeoff 10. Takeoff is just command number 35, for example, on the drone. So basically, what it does is they would have preset a number of possible commands and their integer values. So when I type takeoff, all it does is send the number 35 to the drone, and the drone will realize that it's a takeoff command. And then when I type 10, it will send the integer 10, and then it'll realize it has to take off to 10. So that's why it's so lightweight. Like all it needs is a few kilohertz of processing power because it just needs to process integers. So yeah, learn about Mavlink. It's pretty useful. And also this and also PyMavLink. PyMavLink, like you might guess, is basically a Python interpretation of Mavlink, and this is by far the most useful thing that I have tried learning. This was out of my interest. This is not part of the session that I was going to teach here, but I strongly recommend you guys learn about this. PyMavLink basically lets you control a drone without typing commands. It can run it with Python commands. So in the example that I had given, where you can script a mission where it goes around and it does computer vision, it sees the highest body temperature human, and then it follows them. That you can do with Python with OpenCV. And then to control send drone commands, you can use PyMavLink, the module PyMavLink. So it's pretty powerful, as you can see. So I recommend you guys check out all of this. And yeah, that is basically it for this session. Like all I wanted to do is show you guys how cool this can be, how cool drone control can be, and also to like tell you guys that for all robotics applications, in most robotics teams, you will have to use Gazebo and Linux a lot. So if you have any intentions of like joining any robotics team or any robotic job, I recommend you guys learn about Gazebo. Uh, Actually, I'll add that here. Learn Gazebo and learn Linux terminal navigation. Yeah. So that's going to be it for this session. Upasna, can you send the attendance? Yeah, thanks. Okay, yeah, and by the way, you can use ROS packages for that. ROS is pretty useful, but again, ROS kind of gets complicated after a while, so I didn't want to teach that in this session. But if you guys are interested and you have time on your hands, definitely check out ROS. For all of you that don't know, ROS is a robotic operating system. I use it on a daily basis for my robotics projects. But yeah, if yeah, you guys can learn about it if you have time. So that's going to be it for the session. One second. So yeah, that's going to be it for the session, guys. I think I'll end it here. The attendance link will be on the post. Oh yeah, you had another doubt you can ask. Named, you had a doubt. You can ask. Actually, guys, if you have more doubts apart from this, you can always send it in the post thing, and you can. I will answer that for you. And Ramasamy, I think you're asking how many sessions we have. This is the last session, so yeah. How can I integrate Python file which has OpenCV and NumPy in autopilot? Yeah, so that is basically PyMavLink. If you can look at PyMavLink, it's basically a module that can do drone control for you. So you can import OpenCV in your Python file will basically import OpenCV, NumPy, and PyMavLink. You will run your drone will have a camera. You will get your camera feed to your Python script over the internet. You will run your OpenCV programs over that camera feed, and then you will whatever result you give. Let's say if it detects a person, it should land. For example, very crude example, but let's say that's what you want to do. What you can do is the camera feed can yeah, so the camera feed will detect a person. OpenCV will give you true when it detects a person, and then you will use PyMavLink to send a landing command. And yeah, wait, let me open this thing. Hmm. Wait, let me. That's weird. It looks like an internet issue, but wait, let me. I've never seen. I've faced a lot of errors, but I've never seen this error. But let me Google it quickly. Okay, I think it's a pretty common issue because this is very common in Stack Overflow, it seems. Yeah, bro, just follow this thing on Google, I guess. So so the thing is, I'm not actually sure because I am only familiar with the autopilot side of errors. Git errors are actually they might be more computer specific, and I might not be able to like Oh yeah, okay. You guys can help each other out. So I'll end this. I think I'll end the session now, or I will leave the session. You guys, if you have any doubts and you want to talk to each other, you can still continue using the chat. And yeah, that will be it for today. Thank you so much for joining. I love teaching you guys. I hope your excitement for drones has only increased now. Yeah, if you have any doubts, you can still ask it in the post session, and I will be more than happy to help you guys. Thank you.